Hello everyone, welcome back to my YouTube channel. This is Pooja of Sri Venkateshwara College of Engineering CSE Department first year. Today I am going to discuss some interesting parameter of animation which involves in the concepts of physics. Physics of animation bringing characters to the life, unveiling secrets of realistic animation where physics play a crucial role in creating belief moments. In this presentation you come across as animation that involves in the concepts of physics. Physics of animation. Let us explore the principle of physics influencing the art of an animation, creating the realism and captive motion. Let us learn physics principle in animation. Force and motion, gravity and acceleration, mass and momentum, collision and impulse. The foundation of animation defining how the object moves and interact in force and motion. Motion. Motion is defined as a push or pull acting upon an object. As a result, it interacts with the another object. Force. Force is defined as a change of position over a time. It happens when you apply the force. Gravity and acceleration. Gravity. The force that pulls the object towards the ground is called as gravity. Acceleration. Acceleration is defined as the rate at which an object's velocity changes over a time. Gravity and acceleration explains how the object fall, rise and change their speed. Mass and momentum. Mass. Mass is defined as the amount of material in an object. The unit of mass is kilogram. Momentum. Momentum is defined as a measure of an object's motion. Momentum is a vector quantity. The unit of momentum is kilometer per second. Mass and momentum explains the relationship between the object's weight and its inertia. Collision and impulse. Collision. When two objects collide, they exert a force on each other, causing a change in momentum. Is called as collision. Impulse. Impulse is defined as a force that acts on an object during a collision. Collision and impulse explains how the object interact upon the impact. Motion and force. Newton's law. Newton's law explains the object moves and interact with the force. Newton's first law. Newton's first law explains law of inertia. When object is at rest or in a motion in a straight line at a constant speed unless acted upon the external force. Example, a book on a table stays at rest until you push it. Newton's second law, law of force and acceleration. F is equal to ma. F is the force, m is the mass, a is the acceleration. Example, a heavier object or a greater mass require more force to accelerate than the lighter. Newton's third law, action and reaction. For every action, there is an equal and opposite reaction. Example, when you push against the wall pushes back with an equal force. These laws are the foundation of classical mechanics and are essential for understanding how the object interact in the physical world. Force vector. Force vector is a vector quantity that has both magnitude and direction. Force vector represents the direction and strength of the force. Velocity and acceleration. Velocity is a vector quantity that describes the speed and direction of an object. Velocity and acceleration explains how the speed and direction changes over a time. Gravity and acceleration. Constant force. Push all the object towards the center of the earth is called as constant force. Example for constant force are gravitational force, tension in a rope, rocket thrust in a space. Free fall. Objects move without any initial velocity. It moves under the influence of gravity. Free fall is due to acceleration due to gravity, no air resistance, uniformly accelerated motion. Terminal velocity, the maximum speed required to reach during the free fall. Example for terminal velocity, a skydiver falling through a air. Mass and momentum. Mass, the amount of matter in an object is defined as a mass. Example, a sheet of paper 0.0045 kg. The momentum as a measure of an object's motion. Momentum depends on both mass and velocity of the object. Collision and impulse. Impulse. Change in the momentum during a collision. Elastic and inelastic. Type of collision based on conservation of energy. Friction and drag. Friction. The force opposing the motion between the surface is called as friction. Example, walking, driving a car, writing, etc. Drag. The force opposing the motion through a fluid is called as drag. Example, walking through water, moving your hands through air, etc. Air resistance. Drag experienced by an object moving through a air is referred as air resistance. Example, riding a bicycle, flying a plane, etc. Rotational dynamics. Angular velocity. Angular velocity is defined as rate of rotation. Example, a race car on a circular path. Torque. Torque refers to the rotational force. Example, during a turning of a steering wheel. Moment of inertia. Resistance of rotational motion is referred as moment of inertia. Example, the simple pendulum revolving and the revolving car in a stunt, etc. are the examples. Applying physics in animation. Using the principles, the animator create belief and engaging the moments that enhance the storytelling and immersion for the viewers. Putting it all together, interacting in the physics animation by understanding and applying all these principles, we can create an animation that feels natural and dynamic and believable. Thank you for watching. I hope all enjoyed in this explosion physics in animation. Thank you.